What happens when sharks and fisheries overlap? What is depredation and why can it become an issue for fishers and for sharks? And what things are being done that can help mitigate those issues? All of those questions and more are answered today as we're joined by Dr Victoria Camilieri-Asch. I'm Mark Stokes-Packer and you're listening to Series 2 of the Shark Trust podcast. Vic, welcome to the podcast.
Thank you, Mark. Thank you for having me.
We're going to start nice and simple. Can you let everyone listening know who you are, what it is you do, and where you are?
Sure. My name is Vic. I'm a French-Australian marine scientist. My research has been focusing on shark behavior, sensory biology, and conservation. For the past few years, I began my academic journey in Australia back in 2010. And I have a vet background from Europe as well, so an ingrained interest in ecology or animal behavior. I like to focus on how sharks perceive the environment and how they interact with human activities, and use technological advances and close collaboration with stakeholders to find practical solutions to mitigate shark depredation, shark bycatch. I'm currently based in Germany for a fellowship, but I'm otherwise based in Brisbane, Australia.
Absolutely amazing. Thank you so much for joining today. Luckily, you're in Germany today, which means that when we're recording, the time difference is only an hour. You've had a very, very interesting route into what you do. What started that route? When did you, because you've got this veterinary background, you've then gone into like sensory and behavior, now also into depredation and like technology. What started it all? When did you decide, I'm going to go for sharks?
Good question. As far as I recall, I always wanted to work in the space of animal behavior. I think one of the earliest spark was visiting French Guiana, which is a French territory overseas in South America, and being faced with some impact of the local fisheries there, seeing some beached rays and sharks and very juvenile sharks. And I think the conservation work that my uncle was doing there really touched me. I think that's what started it all, and I really want to dedicate a career or my life to doing something about it. So that's for the really old memory. As you grow up, obviously your parents tend to push you towards other jobs, and not knowing that you can specialize in shark science. So I've been considering a vet career, which I started, and after a while I wanted to go back to animal behavior, so ethology, and that's what pushed me to make the jump, go to Australia, transfer my credits as a university student, and start specializing more specifically on marine issues and sharks and relatives.
What was it about shark behavior? Because sharks are very interesting, they've got extra senses. You've looked into that. What is it about that you found so interesting? And then can you tell us what it is that you learn?
I think the most interesting thing in those animals is not only that they have an extra sense compared to us, so they have the five sense that we do have, we share that, and they also have the ability to detect bioelectric fields that are emitted from muscular contractions and other physiological activities in any body, in any animal. And I was fascinated by that. Some river dolphins have that, platypus have that as well. But I think what attracted me to sharks in the first place was their vulnerability, the fact that they're not regarded as a charismatic species, or not back then when I was a kid, and needed more attention, needed more protection. And the other aspect that I found fascinating about them is the more I went into neuroscience and evolutionary pathways of different sensory systems, I realized that they are at the base of the evolutionary tree as vertebrates, animal with a column. And they basically have a brain organization which is the same as us, just structured and organized a different way. So they have a biplan brain with same 5 main brain regions that integrate stimuli information plus that extra sense that I've talked about. And I became fascinated by the fact that they are our ancestors in a way, evolutionary speaking. And what other animals can do, they've developed that brain with other primitive fish groups as well, that initial brain structure.
Wow, that's actually very interesting. I know nothing about shark brains, so that's really, really cool.
I had a key phenomenal mentor, Kara Yopak, based at University of North Carolina, Wilmington now. And she's the shark brain guru. And we delved into so many topics, including the one that I just discussed. There is a lot of fascinating facts to discover.
So cool. We could do a whole episode on shark brains, which maybe could be a future one. I'll write that one down. Now, the amazing thing about these extra senses, all the stuff you've done, is that there's currently this episode or this series about living with sharks and how sharks and people overlap and how that can be positive, but also can create some negatives. And one of those is depredation. So you're on here because you are amazing expert in that. Could you tell us, for people who are listening for the first time, about what depredation is? Can you tell us what it is, and what does it look like in real life?
Absolutely. So depredation is a word that's been coined in the last 3 decades, I think. But it's commonly called in the field bite-off. So it's the partial or complete removal of a fish caught on a fishing gear by predators, not only by sharks, so also dolphins, whales, seals, or larger marine animals, before the catch can be retrieved on the vessel or landed.
You said there, because you said it's not just sharks and it could be other animals as well. So I cover our social media, so I'm on social media quite a lot. I can't say the name of the account because it's got a swear word in it, but there's the tax man is. I thought it was quite funny to watch because they're quite comedic videos. But I didn't know what depredation was. But it's basically groupers, sea lions, and sharks usually taking catch from things. But my favorite ones are always the seals and the sea lions. Not for the commercial ones, because I kind of feel a bit bad because they're trying to make a living. But some of the sport fishermen, they'll be like posing with their photos, and I think it's like a mahi-mahi, like the big green fish. And you just see this sea lion's nose like peek up at the side of the boat, and then he like sneaks up, grabs the tail, and he's taking it. That case, obviously, the fish is already out of the water. But yeah, so some people, I knew about it a couple of years ago, but I've probably only known about it in the last year as an actual thing that can cause issues.
Yeah, it started to pick up roughly 15 years ago. A review led by Dr. Mitchell and colleagues at the University of Western Australia at the time just assessed the level of interest and the level of urgency of that challenge worldwide. And it clearly picked up roughly 20 to 15 years ago. And it matches anecdotal reports showing that it's being reported more, it's being talked about more by the fishing communities around the world since that time. So there has been a shift, noticeable enough for people to start talking seriously about it and start getting funding available for research about it, probably 20 years ago or so. So it's fairly recent, and it's a big field. It's becoming a big field of study now. So very interesting space to be in.
Do we know why it happens? Like, is it that in some areas there's more sharks, so you're kind of competing for the same food, or are the sharks that they're maybe just a bit smarter, so when they know that there's potentially going to be an easy meal, they're going to go for it? Do we know that?
Well, we know a couple of things, and we don't know a lot of things still. So research over the past few years obviously has really helped improving our understanding of shark behavior around beach safety, also fishing vessels and other kind of activities, but particularly in fisheries. But in saying that, we have a lot of gaps remaining. So scientists know currently that some sharks are attracted to fishing activity because of hooked fish, discarded bait, fish waste, which all provide a feeding opportunity and is a source of food. Acoustic tracking studies have shown that certain shark species repeatedly visit certain areas where fishing vessels operate on a regular basis, where some individuals have learned to directly associate boats with food rewards. It's been shown. Those are called depredation hotspots when there is a spatial and temporal overlap, and it's being linked to both shark movements and fishing patterns. But overall, researchers still do not fully understand a couple of things: how sharks locate the hookfish or fish waste, which combination of sensory cues, sound, smell, vibration or visual signals in the water, which ones are the most important, or how quickly these shark species involved learn this behavior. We also don't know whether depredation is driven primarily by a small number of specialized individuals that quickly learn that, or by broader population level behavior. What we do know from very localized studies is that in Exmouth, for instance, Australia, another study led by Dr. Langlois and Mitchell and colleagues showed that certain shark species learned to associate the presence of boats in new fishing location in just 6 days, which is pretty impressive. But that was specifically for those shark species that they've looked at. There is also current evidence suggesting that environmental conditions combined with shark abundance, fisher behavior as well, and fisher knowledge all influence depredation rate. And it's been shown in the Pacific, around Oceania regions as well. Overall, worldwide, 30 different species of sharks have been found to be involved in depredation events to date. And so as a result, you can imagine that predicting when and where sharks will interact with fishing gear remains a major challenge for fisheries management and also shark conservation. So that's really what is coming through currently, that fisher-sharks interactions in the form of depredation and or bycatch, because they are interlinked, are a multifaceted challenge, and it's occurring worldwide.
You said there, like, obviously there's loads of different factors that kind of play into it, like different conditions. And you said there's also fisher behavior. Is that as in like where they're choosing to fish, or the gear they're using, or what comes into that?
So there is a couple of things there. When I say fisher behavior, it's the change of strategy that they may be using, and I will cover that. It's also the influence or induced change of behavior due to change in bag limits and due to size limits as well, which will shift the way they practice their fishing. It's also the fishing tourism that has changed or is changing in certain locations where new fish species appear and it becomes lucrative to create a tourism opportunity. So there is a couple of things with fisher behavior, which is also interconnected with local socioeconomics and demographic as well, and overall location. For fishers, so like I said, shark depredation is rather a multifaceted issue with several level of impacts, not only on fishers, but also on sharks, evidently, and the marine ecosystem overall, and human attitudes towards sharks. For fishers, to start with, depredation causes loss of valuable target catch. It damages their fishing gear. It also forces them, as such, to spend more time in the water, so increase the operational cost, increase frustration when target fish is partially or completely eaten because it can't be used for commercial purposes. So in some fisheries, fishers spend more time and money catching replacement fish, which increase the overall fishery operational cost, like I said. And for recreational fishers in the tourism industry, it reduces the enjoyment that they experience around fishing, and they're constantly losing priced fish. For catch and release fishery, it's the same. For instance, the ones targeting large pelagic fish in certain areas. So overall, it increases a negative behavior towards sharks. For sharks themselves, depredation can increase their interaction with fishing activities, leading to higher bycatch, injury, and potential mortality. Some sharks may become conditioned to associate fishing vessels with an easy food source, like we said earlier. So it alters, to some extent, their natural behaviors. And we certainly saw that with some acoustic tracking telemetry studies, where sharks spend way more time in certain locations than others, locations where fish waste is being disposed at sea. So that's just one example. Research has also shown that negative fisher response can result in retaliatory killing of sharks in certain communities. So it creates additional conservation concerns there for already vulnerable population, depending on the area. Another point I wanted to make is that sharks may retain, when they depredate, they often go for the full fish, so they get hooked themselves, which is called bycatch. And when they're being reared to the boat, that's where a fisher can decide to cut off the line and let them go. In that case, they might have a trace or a long line and a hook in their mouth or digestive system for a long time, if they're a juvenile, for instance, which can create physiological issues down the track. Or they might be removed from the ecosystem out of retaliation. So that's the main impacts to sharks. So as a result, they might have a difficulty, a lesser ability to feed, secondary infection, and death in some cases. So that's pretty much what sharks are facing. On an ecosystem level, depredation leads often to a greater overall mortality of target fish, because fisher will often continue to fish until they reach a certain quota of their bag limit for that species or for given species. So all the extra fish that they lose to depredation count on top of those retained and landed and reported about. So there is sometimes the double amounts of fish being removed from the ecosystem, but only half of it is reported, for instance, if depredation rates are not reported. So it creates a big challenge for management. So over time, it could reduce even the sustainability of some fisheries, lead to population declines of target species. So accounting that extra mortality is important when assessing fish population, and when establishing fisheries management measures, collecting data on depredation rate to allow this has only been occurring recently. So that's something to press on. So overall depredation influences on different socioeconomic, political, ecological, and governance level, rather negative attitudes towards sharks. And recent social science studies have shown that and found that repeated depredation events or increasing depredation rates increase frustration, reduce support for shark conservation in certain areas in the world, and foster that perception that sharks are here to tax and are a threat to fishing livelihood, and are not to be supported in a coexistence dimension, for instance. So in some cases, fishers experience a lot of depredation, and those report usually really high negative attitudes towards sharks, even promoting the reopening of some targeted shark fisheries in certain areas. So researchers in the world, colleagues worldwide, now view shark depredation as a really complex human-wildlife conflict that requires working really closely together with local communities and local governance.
You've gone into how complex it is and bits that I've not even considered. So you've got obviously the issues with the fishing gear, like the cost of that, the losing of their target catch, the then potential negative perceptions of sharks, and could even have retaliation, also an increased risk of bycatch. But that ecosystem element that I hadn't even considered, where the fishermen still need to catch their fish, so they're going to continue fishing until they reach their quota, so potentially double the fish coming out. Is there a certain type of gear which depredation occurs more often in?
To avoid depredation, there are a range of measures that fishers around the world have implemented during their fishing practices, and that research also has found being helpful to reduce the risk of depredation when out on the water. And so there is a range of practical measures that can help. This includes moving fishing location frequently, avoiding fishing near other fishing vessels, and create that vessel activity hotspot that attracts potentially more sharks. Moving on, once depredation events occur, moving on pretty much straight away to a new location and quite fast. Using electrical reels and hand lines also to retrieve fish faster has been shown to reduce depredation in some cases. Using lures and jigs instead of bait tend to decrease the level of cues in the water and attract less shark. depending on the shark abundance and density in given location, and also diversifying the target species. Diversifying the catch is one of the key factors that can really help. Not dumping fish waste at sea is another big one. For instance, one of the studies that, as part of the Lord Howe Island shark research program, the telemetry work combined with vessel tracking really identified one of the key hotspots, and one of these key hotspots was a fish waste disposal area that has been used for the past 2 to 3 decades, pretty much when the issue starting to be reported more and more. And we found out that even after creating a new system to get rid of fish disposal on islands, on land-based, sharks still showed up. Even juvenile sharks still showed up at that location for a couple of years since the program exists, since 2017. So it shows that, based on what I said earlier, that sharks can learn potentially quickly to associate areas to new opportunistic food grounds, but it can de-learn not that fast at all, and we don't know how much of an impact that behavioral association has on individuals and on a population level over time. But clearly, it's something that does impact their natural behaviors.
That is very, very interesting. We're going to take a really quick break now to hear from our sponsor of the podcast. So please stick with us through this ad break, and we're going to go into what Vic has been working on to mitigate those depredation. This episode is brought to you by Surfears, the earplugs that let sound in but keep water out. Perfect for diving, surfing, or snorkeling. Surfears 4.0 feature a re-engineered fused core and mesh design, paired with tough silicone rubber, making them more durable than ever. They're designed with sustainability in mind, using materials like ocean plastic and recycled silicone. We've tried them, and honestly, they're a game changer. Comfortable, eco-conscious, and they actually work. Thank you, Surfears, for sponsoring this episode and keeping our ears happy and healthy. Thank you for sticking through that break. We're going to jump straight back in, Vic. Picking up from what you were just talking about, what are the key drivers of depredation for sharks? Or key things that are causing depredation for sharks? Do we know what they are? Are there any unknowns? And where do we go once we know that stuff?
Yeah, so as I said before, there are a couple of drivers well known, including fisher knowledge and behavior, the level of discarded bait in the water, fish waste disposal is another factor, environmental conditions, sea surface temperature, shark abundance. All of that can be factors depending on the context, the shark species, and the location. Another unknown factor is understanding whether depredation constitutes an important part of the diet of sharks in some cases, and whether it gives them access to feeding on different fish species that would be more nutritious or metabolically advantageous for their survival. And we talk about species that they wouldn't be able to catch naturally, and for them to be able to access them only on an opportunistic basis because they are being injured and incapacitated on a hook.
How would you look to see whether there is a different change from the fish that they're eating, whether that's better for them? Would that be like because I'm also not a biologist either. How would you work out if that is a factor that's driving this?
So we would look at different things. We would look at the baseline knowledge on the diet of that particular species involved, depending on the case study or area. So in our case, we work a lot on the Galapagos shark, and we have collaborators working on remote island system close by to where we are, where the program is based in Australia. The best way to look at diet impact on shark behavior would be to gain knowledge of that baseline diet using stable isotope analysis and fatty acid analysis. What that entails is taking biopsies of the muscle of these sharks and fin clips and working out the composition of the tissue, which reflects what they've been feeding on, using biochemical assays. I'm not an expert in that field. We work really closely with collaborators who are leading that field. at Flinders University and at Griffith University.
And I get, so they could be getting potentially fish that maybe have different nutritions in their diet, which could drive them, but then they're also potentially using far less effort to catch those fish as well. So in terms of the shark, it could be kind of like a win-win. And then to fisher, it's a lose-lose. You've also been doing some really, really cool technological stuff, which I really want to get into. Can you tell us a bit about your work on the Keeling in the Cocos Islands? What was happening there, firstly, with shark depredation? And then, can you tell us a bit about that study?
So Project Cucut, which means sharks in local Cocos Malay language, came about after community consultation that identified that shark depredation was one of the biggest fisheries management challenge on island that the local artisanal fishers are facing, and was developed collaboratively during the development of the new Indian Ocean Territories Marine Park in Western Australia. So that's for the setup of the study itself. But from the onset of this research, our team has partnered with a community-led fisheries management group called Cocos Marine Care, combined with community fishers, charter operators, elderly groups, to co-design and also local governance, with marine park staff and representatives. And so we all sat down together and co-designed a project that would test potential practical solutions for this locality. So we could gain local knowledge and historical knowledge, most importantly, about behavioral shifts in fisher themselves, the community consultations across different groups, and the overall feedback through social surveys really shaped the study design and the technological trials that we would run, and was completely integrated in this research, similar to previous and ongoing work at other island systems we work at across Australia.
How important is it to have that local ecological knowledge?
It's crucial. It's becoming a central point across many studies now, without which we couldn't foster a successful research project to start with, but then deliver outcomes that are sustainable and can really be implemented on a long-term basis.
Fantastic. I think, it's important to highlight that it's not, scientists might have an idea about something, but they can't just go somewhere, be like, yep, this is the answer, here we go. It's really important to have all of those stakeholder views, because the people who are there seeing it every day are going to know a bit more than someone who's kind of over here and they just come in every now and again. So it's really good to hear that you guys are working so closely with them. Are you happy to start talking about the Shark Guard device? Yeah. Can you explain it to someone who has never seen one before? They don't know what it is.
This specific study at Cocos Keeling Islands tested a commercially available electrical shock deterrent device called Repelex. It's specifically designed to reduce shark depredation and potentially bycatch. So if I had to explain what this device is about, it's a long dipole, so similar to the shark shield device surfers or divers have been using for the past few years now during underwater activities. So it's a very long device with two electrodes. There is an electrical magnetic fields being created along that device. But being in a fishing setting, the device is clipped directly on the line. So it's usually placed 50 to 60 centimeters above the hook. The clever thing about that device is that the bottom electrode is hollow, so it's a floating part. So when the line is soaking in the water until a fish is being hooked, it's actually floating away, so visually not disturbing fish catch. And so when a fish is hooked and the fisher can sense it, the line is being reared and that device is being placed naturally by a physical force against the line and surrounding the fish. So the goal is to create a strong electromagnetic field around the catch target species and deter sharks willing to approach and take it. And this is all based on the sensory biological knowledge of sharks species, having that extra sense of detecting electrosensory cues compared to the rest of the fish not having that capacity. So it would, in theory, not deter target catch and deter only elasmobranchs, so sharks, rays, and cartilaginous fish. So it's based on that principle.
And is it working to like almost like overload the senses? Like how does it actually work?
Pretty much. So it's exactly right. So in principle, it's supposed to overstimulate their sensory systems and make a very noxious and create an unpleasant reaction, if you like, a bit like when we get ourselves electrocuted on a barrier or something like that. In reality, sharks and rays have been shown to be sensitive to very low. When we talk about bioelectrical fields, it's really muscle contractions. It's tiny. It's things we don't have the capacity to sense, right? And they are able to detect that through sand for hammerhead sharks and locate prey without visual cues at all. So we talk about really tiny amounts for the physicians out there. For certain ray species, it's down to nanovolts per centimeter. It's really small signals. So when those stakeholders or industry partners develop deterrents that use up to 50 or 200 volts, it's more than overstimulating their electrosense capacity. It's really like creating a strong reaction for them to turn away, basically.
How does it work when you wanted to go and do this study? What does that look like? Are you out like on fishing boats?
So like I said, yeah, that device is targeted to deter sharks because they're highly sensitive to electrical fields compared to other fish. And for instance, at Cocos Keeling Islands, the testing trials were run over 11 days of deepwater bottom line fishing, which reflects local artisanal activities there. So it's not out of context. So we usually match what's being done locally in terms of fishing activities. We worked with 6 local fishers. It could be more or less depending on where you are. So totally as part of normal fishing activities. But we had fishing observers, researchers on each vessel collecting the data and on the effectiveness of the device and its practicality as well, and reporting on everything. And for instance, during that trip, just as an example, more than 250 fish were caught across more than 50 fishing sessions, and the results show that the device reduced the probability of shark depredation by 63%, while also reducing shark bycatch and fishing gear loss as well. So fishers reported being able to successfully fish, which is an interesting fact, in areas where they had not fished for a long time because they couldn't land anything. Depredation was, the rate was up at 100%. So they avoided actively those areas because of high depredation rates. And for the first time, we really wanted to test the device in the biggest hotspots, if you like. The device enabled them to land fish again.
I mean, that's absolutely amazing that it's able to do that. Is those devices, are they like quite expensive? Like how do the fishers get those devices so that they can use them?
Yep. So as part of this work, we always include a practicality assessment, and that also includes socioeconomics. So most of these devices, there are more now since on the market, being developed and being available to the public. They roughly cost around 300 Australian dollars. They're around that mark. For commercial fishing operations, certain stakeholders develop very cheap deterrents because those fisheries need hundreds of them. But for the public practice, charter operators, local fishers, and tourism fisheries, for now, this type of device, unfortunately, are around the 300 mark.
I mean, it reduced bycatch by like, did you say 63%?
Yeah, so the Cocos Keeling Islands Project Cucut found that it reduces depredation by 63%. At another island system we work out and tested that device, it reduced it around the same percentage as well.
Huge amount, which could be, I mean, great for obviously the fishers themselves, but also good for the sharks because they're not, you said, a reduced bycatch as well. And then hopefully there's those less negative interactions between sharks and people. Due to the kind of placement of it on the line, say those in that 37% where depredation still occurred, did the device still stay on the line, or did that fall off, or how does it? Yeah, because obviously it's £300, you don't want to lose it.
Yeah, no, that's a logistical point of interest for sure, and that's part of the practicality assessment as well, because it has to be durable. So we took into account any gear loss and fish gear loss, including deterrent loss. It did happen, but on very rare occasions. It was actually more due to snagging for long device such as the Repelex. Other devices are a bit smaller. Other device we tested didn't have that effect or that inconvenience. It just depends on, I think it really depends on the condition at the local fishing area. Some areas, for instance, have really strong currents, isolated islands, and in this particular context, for instance, the Repelex will still float, like I explained earlier, but because the line would be at a higher angle due to the currents, the floating device will be quite close to the line, so that can create entanglements, which might reduce the target catch as well. Even in instances where the target catch was reduced in either of the study sites that I've mentioned, the offset from reducing the depredation rate was greater. So overall, there was more fish still being landed on the boat in any case. So any of those studies, including the Cocos Keeling Islands case study, showed that deterrent technology can really provide a non-lethal tool to reduce depredation and bycatch and improve socioeconomics for local fisheries and also promote coexistence, hence help shark conservation locally.
What are the next steps of this research? Or is that it and you're like, yeah, this device is the one that we're going to use? Or are there other devices you need to test or ways that the device could be improved?
Yes, so at Cocos Keeling Island, for instance, as part of that work, obviously being a complex atoll system, we tested bottom line fishing, but there was all the sites as well where depredation occurs with different species as well. So even within an island, you have slightly different fishing contexts. So for the Project Cucut, for instance, the fishers also tested a new prototype version of the Repelex the manufacturer is working on, more targeted at pelagic fishing. So the design would be slightly longer with the sleeve and a system of release that would allow or increase the effectiveness of target catch and reduce depredation at the same time. And early trials showed that there is a reduction in depredation by up to 90%, which is quite promising. So more recently, scientists focusing in this area of research have reviewed all mitigation tools that have been developed, tested, and are currently available worldwide on the market in the hope to develop a standardized approach to assess and test effectiveness and practicality of all these devices and top rank the methods that need to be tested first as a priority on a wider scale, and that all of that to guide future technology development. So that's to come.
I think that would be so helpful if you've got all of the devices and then the different types of fishing that it would help the most. Just because then one, it's cool to just know, but it's going to help. It's going to help the fishers, the anglers who are doing it, so they know what to buy. And then hopefully reduce that conflict.
Yeah, and for manufacturers as well, we really need to have that open conversation about what's most useful out there, because we need to ensure that not only it's efficient, that there is potentially no or very limited habituation from the sharks, and which is also something that needs to be tested in many fisheries and shark species, and that it can be uptaken as well. We need to make sure that the uptake from the public is there. And for that to happen, the testing needs to be done in a standardized manner across fisheries to reinforce that trust that there is a tool to really help.
Thank you for listening to part 1 of this episode of the Shark Trust podcast. If you have enjoyed it, please like it, share it with people who you think will like it as well, and give us a rating. If you give us a rating, we can reach new audiences, will appear in their podcast feeds. Thank you to our sponsor, Surf Ears. Please protect your ears. Please, please, please. And also the Revolution Studio, who do our podcast artwork. Video and sound editing has been by Louis Hogan. Research and planning by Kat Gordon and myself. I'm your host, Mark Stokes-Packer, and you've been listening to Series 2 of the Shark Podcast. Make sure you listen to Part 2, which is coming out today as well.